So this is lesson 3.4, adding and subtracting rational expressions. We're going to kind of walk through the steps and get you started on it. Our goals are to be able to do several different things. First of all, we want to find a common denominator. Second, we want to use that common denominator to help us multiply rational fractions. And then from there, we're going to add and subtract. When adding or subtracting, it's important to remember that you have to have a common denominator. And this goes back to like fourth grade when you were learning about your basic fractions. Okay, so if we take something like 3/4 plus 5/8, we cannot just add those. We have to first put them in terms of the same unit, essentially. Okay, so 3/4 plus 5/8, I can very easily change 3/4 into 6/8, right? Because 4 times 2 is 8 and 3 times 2 is 6. Now that I have 6/8 plus 5/8, I can add those together and I get 11/8. No need to reduce or no need to write it as a mixed number. We're going to leave it as an improper fraction, okay? So let's try this with some variables. First of all, we want to find a common denominator. In this case, 5 goes into 10, kind of like 4 and 8. So that's going to be our common denominator. So I'm going to rewrite x over 5 in terms of tenths. Whoops. So x over 5 is 2x over 10. What I did is I multiplied 5 by 2. Why does this keep switching? There we go. I multiplied 5 by 2 to get 10. So then I need to multiply x by 2 to get 2x. Then, once I have common denominators, I can simply add 2x plus 3x is 5x over 10. I should reduce if I can, okay? And in this case, because I can divide a 5 and a 10 out of, or a 5 out of both 5 and 10, I need to do so. And that gives me x over 2. And that is my final answer. Okay, so 7 and 15 don't have any common factors. So in this case, the common denominator is going to be simply 7 times 15. So sometimes it works out where like one does not go into the other or whatever. So we just end up multiplying them together, okay? So 7 times 15 is 105, which is going to be my common denominator, if my pen will write. There we go. So 7 times 15 is what I'm multiplying by. So I'm going to multiply the top by 15 as well. And 9 times 15 is 135. X. And then the second fraction, I'm multiplying by 7 on the bottom. So I'm going to multiply the top by 7 as well. And I get 7x. Now what's left is for me to simply subtract those. And 135 minus 7 is 128. X. Whoops, forgot my X. Over 105. And I don't think that's reducible, so I don't know why my 1 wrote like that. There we go. So then that would be our final answer. We'll try another one here. 9 and 21. 9 does not go into 21, but we want to find their least common multiple, which is going to be 63. Now, how do I know that? Okay. Why didn't I just multiply 9 by 21? I could have. That would be what? 189. But I want to go with my least common multiple just because if I go with the 189, I'm going to have to reduce. It'll work. It'll still work. You'll just have to reduce your final answer. But I know that 9 times 7 is 63, and 21 also goes into 63. So that's why I went with that one. Okay. So this first fraction, I'm multiplying by 7 because 9 times 7 is 63, which gives me 7x plus 7. Don't forget that you are distributing the 7 to the x plus 1. And then over here, I'm multiplying 21 by 3 to get 63. So I'm going to multiply 4x by 3, and I get 12x. Now I just need to combine like terms. 7x plus 12x is 19x plus 7 all over 63. That's my final answer. So you can see it's getting a little more complicated, but still pretty doable. We can figure this out. Now we're going to throw some variables into the denominator, okay? So what is a common denominator for 8 and x? Well, we talked about this. If they don't have any common factors, we simply multiply them by each other. So our common denominator is going to be 8x, which means that I'm going to multiply this first fraction by 8 and the second fraction by x. So when I multiply 9 by 8, I get 72. And when I multiply 5x by x, I get 5x squared. Now all that's left is to add them together, and since 5x squared and 72 are not like terms, I'm just going to rewrite them. That is my final answer. There's nothing I can reduce, so I'm good. 3x and 9. Let's figure out a common denominator here. So 3 goes into 9, which means that I can use 9, but I also need that x in there. So I'm going to make this 9x because 3x times 3 is 9x, and 9 times x is 9x. Now I just need to multiply the numerators. So 3 times 4 is 12. 8x times x is 8x squared. Then I'm going to combine, which I can't really combine anything because there are no like terms. So I'm going to leave it as 12 minus 8x squared over 9x, and we are done. Now, sometimes it's going to be very helpful for us to factor first. For example, if I factor this 3x plus 6, I can see that that is 3 times x plus 2, which so happens to be my other denominator. Because I can multiply the x plus 2 times 3 and get 3x plus 2, that is going to be my common denominator. Now, when we start getting a little more complicated, instead of writing them as separate fractions, I sometimes like to write them together and then just combine the numerators on the top. I find that a little easier. It uses a little less paper, I guess. So I'm going to multiply 3 times 3, which is 9, plus. And then I'm going to multiply 4x by 5 times nothing because I already have that common denominator, so I don't need to do anything to that second fraction. So now all I need to do is combine like terms, and 9 plus 5 is 14. And we're going to leave it over 3x plus 2. Remember we talked about leaving it in factored form? Because now I could go on and I could find the asymptote, I could find the intercepts, like all that kind of stuff. So we're just going to leave it in factored form. This is completely acceptable, okay? Now, again, we want to factor. I'm going to start with this one because it's a little easier. Anytime I see that x squared minus 1, minus 4, minus 9, I know that's difference of perfect squares. Now, if I come over here, let's think about factors of 1 that add to be 2. Well, how about 1 and 1? Whoops. And since they're both positive, I'm going to make it x plus 1, x plus 1. Now, I need a common denominator that incorporates all of the different pieces. So I know I need an x plus 1 because that's in both of them, right? But then I need another x plus 1 to account for the 2 that are on the left-hand side, and I need an x minus 1 to account for the x minus 1 that's over here. So my common denominator ends up being x plus 1, x plus 1, x minus 1. Now, I got to figure out what to multiply each fraction by. So I'm going to multiply the numerator by what's not in the denominator, okay? So over here, I'm going to multiply the 3x plus 3 by the x minus 1, because that's what is not in the denominator, which gives me, I'm going to, of course, FOIL this out, 3x squared minus 3x plus 3x minus 3. That's my first numerator. Now my second numerator, I'm going to multiply by x plus 1 that I'm missing from the denominator. And I get, let's see, x squared minus 1. Now I need to go through and I need to combine like terms. Well, these are going to cancel. And I have 3x squared minus x squared is 2x squared. And I have negative 3 minus negative 1, which is negative 3 plus 1, which is minus 2. Oops. All over x plus 1, x plus 1, x minus 1. And there we go. Okay. I don't think I can reduce that. I'm just thinking about, can I, you know what? Let's factor the top and see. So let's x squared minus 1. Oh, yep, sure enough, I can. Okay, so the x plus 1 here cancels with this one here and the x minus 1, which leaves me with a much simpler version of 2 over x plus 1. Now, I want to go back to the beginning because remember we always talk about factor first, right? I did not factor this 3x plus 3. What if I had? Do you notice that the x plus 1 and the x plus 1 would have canceled? And then that would have saved us from canceling at the very end. So sometimes by factoring and simplifying at the beginning, you can get a little simpler version and don't have to cancel as much at the end, okay? Just kind of keep that in mind. So let's go through and factor everything that we can. So here I'm going to take out a 2. There's nothing to factor on top. The top right cannot be factored. So then let's factor on bottom here. So what multiplies to be 3 and adds to be -4? Well, -3 and -1. So it looks like my common denominator is going to take all the different pieces. So 2x minus 1, x minus 3, okay? Which means that the right fraction is going to be easy. I'm just multiplying by 2. The left fraction is a little bit more complicated. I'm going to have to multiply this by an x minus 3. Okay, so I'm going to go through and I'm going to multiply out the top here. So x squared minus 3x plus 2x is minus x, minus 6. Now I'm using parentheses because I don't want to mess up my signs, okay? That's kind of important. So I'm going to multiply 2 times negative 2x is negative 4x, and 2 times negative 1 is negative 2. Now I'm going to go through and I am going to combine my like terms, being very careful to watch that minus sign and make sure I don't mess up my signs, okay? So x squared, there's no other x squared to combine with. Negative x minus negative 4x is negative 1 plus 4, which is 3. And negative 6 minus negative 2 is negative 6 plus 2, which is minus 4. Now remember, I want to see if I can simplify, okay? So I'm just going to factor the top real quick, and I get x plus 4, x minus 1, because 1 times 4 is 4, and 4 minus 1 is 3. Now, the x minus 1s cancel out, and I am left with x plus 4 on top and 2x minus 3 on bottom, and that is my final answer there, okay? So always kind of check just to see if it can be reduced, and then do so if you can. All right, let's try another one here. Let's go through and factor. This might be a good time to pause the video and see if you can factor yourself. I've got this all factored out. My common term is the x minus 4. So I'm going to include all of the different pieces. I'm going to multiply this first fraction by 12. So I get 12x. And this second fraction I'm going to multiply by x plus 3. And I get 5x plus 15. Now I just need to combine like terms. And I get, let's see, 12x plus 5x is 17x plus 15 over 12, x minus 4, x plus 3. I already know it's not factorable because 17 and 15 have nothing in common. So my answer is this, and I am going to leave it alone. So I'm hoping that you're kind of understanding how to find a common denominator, how to then multiply each fraction, and then finally to add or subtract. you have some practice to do with this, and then we will be able to discuss it further when I return, hopefully on Wednesday.